Hi, this is E. Shravani from AIML Section C. Here I am to speak on integral and Hermitian matrices. In this video, we're gonna cover about what is a Hermitian matrix, examples of Hermitian matrix, properties of Hermitian matrix related to Hermitian matrices. Firstly, what is a matrix? A matrix is a set of numbers arranged in rows and columns so as to form a rectangular array. The numbers are called the elements or entries of the matrix. Here you can see an example. This is a matrix of m by n matrix where m are the row number of rows and n are the number of columns. Here the first element is A11, E12, E13, so on. And the second row A21, A22, A23 and so on. What is a Hermitian matrix? Hermitian matrix has a similar property as a symmetric matrix and was named after the mathematician Charles Hermite. The Hermitian matrix has complex numbers as its elements and it is equal to conjugate transpose matrix. Let us learn more about Hermitian matrix, properties of Hermitian matrix, terms related to Hermitian matrix and examples on a Hermitian matrix. What is a Hermitian matrix? A Hermitian matrix is a square matrix which is equal to its conjugate transpose matrix. The non-diagonal elements of a Hermitian matrix are all complex numbers. The complex numbers in a Hermitian matrix are such that the elements of the ith row and jth column is a complex conjugate of the element of the jth row and ith column. A equals to A transpose conjugate. Also, Aij equals to Aji bar. The matrix C can be referred to as a Hermitian matrix if A equals to A transpose. A Hermitian matrix is similar to a symmetric matrix but has a complex numbers as the elements of its non-principal diagonal. Hermitian matrix is a special matrix. Etymologically, it was named after a French mathematician Charles Hermite, who was trying to study the matrices that always have a real eigenvalues. The Hermitian matrix is pretty much comparable to the symmetric matrix. The symmetric matrix is equal to its transpose, whereas the Hermitian matrix is equal to its conjugate transpose, sometimes referred to as transgate. The Hermitian matrix has a complex numbers, however, its diagonal entries are real. The eigenvalues of a Hermitian matrix are always real. Let us learn more about the Hermitian matrices and their properties in detail, along with Hermitian matrix. What is a Hermitian matrix? A Hermitian matrix is a matrix that is equal to its conjugate transpose. Mathematically, a Hermitian matrix is defined as a square matrix A equals to Aij n cross n such that A transpose conjugate equals to A, where A power star is a conjugate transpose of A. That is, if for every Aij belongs to A, that is Aij bar equals to Aij, then A is called a Hermitian matrix. Note, every diagonal element of a Hermitian matrix is a real number. Every real symmetric matrix is Hermitian. Let's see some of the examples of a Hermitian matrix. Hermitian matrix of order 2 by 2. Here the non-diagonal are the complex numbers. Only the first element of the first row and the second element of the second row are real numbers. And the complex numbers of the first row, second element is a conjugate complex number of the second row, first element. Here we can see the example, that is 3, 3 minus 2i, 3 plus 2i and 2. Hermitian matrix of order 3 cross 3. That is 3 by 3. Here the non-diagonal elements are all complex numbers. The elements connecting the diagonal from the first row, first element to the third row, third element are all real numbers. And the other non-diagonal elements are conjugate complex numbers of each other. 1, 2 plus I, 5 minus 4i, 2 minus I, 4, 6i, 5 plus 4i, minus 6i and 2. Here we have a problem, that is finding if the matrix A is a Hermitian or not. Let us consider the given matrix as A. That is E equals to 1, 4 plus 3i, 4 minus 3i and 5. Then conjugate of A can be taken as 1, 4 minus 3i, 4 plus 3i and 5. Transpose of a conjugate of A, that is 1, 4 plus 3i, 4 minus 3i, 5 equals to A. Hence, the given matrix is a Hermitian matrix. Properties of a Hermitian matrix. The following properties of the Hermitian matrix help in a better understanding of a Hermitian matrix. The elements of a principal diagonal of the Hermitian matrix are all real numbers. The non-diagonal elements of a Hermitian matrix are complex numbers. Every Hermitian matrix is a normal matrix such that A power h equals to A. The sum of any two Hermitian matrices is a Hermitian matrix. The inverse of a Hermitian matrix is a Hermitian. The product of two Hermitian matrices is a Hermitian. The determinant of a Hermitian matrix is real. If a square matrix A of order n is a Hermitian, if and only if Aij belongs to A, that is Aij bar equals to Aij. If A is a Hermitian matrix, then K is any real scalar, then Ka is also a Hermitian matrix. Let us take Ka whole to the power theta equals to K into A power theta, that equals to K, since K is a real number. If A is a Hermitian matrix, then A power A conjugate, A transpose conjugate to the power of transpose conjugate equals to A. If A and B are two additional conformable Hermitian matrices, then A plus B is also Hermitian. Terms related to Hermitian matrix. The following items are helpful in understanding and learning more about the Hermitian matrix. Principal diagonal. In a square matrix, all the set of elements connecting the first element of the first row to the last element of the last row represents a principal diagonal. A symmetric matrix. A matrix is said to be a symmetric matrix if the transpose of a matrix is equal to the given matrix, that is, A transpose equals to A. Conjugate matrix. The conjugate matrix of a given matrix is obtained by replacing the corresponding elements of the given matrix with its conjugate complex numbers. Transpose matrix. The transpose of a matrix A is represented as A to the power of T, and the transpose of a matrix is obtained by changing the rows into columns and the columns into rows for a given matrix. Integral matrices. Depending on the special ordering, the notations of the integral and unimodular matrices are defined. The Euclidean algorithm enables us to derive a weak version of elementary divisor theorem, whereas questions of uniqueness are left out of account. Eigenvalues of a Hermitian matrix. The eigenvalues of a Hermitian matrix are always real. Let A be the Hermitian matrix such that A transpose conjugate equals to A and lambda be the eigenvalues of A. Let X be the corresponding eigenvector such that Ax equals to lambda X. Then X to the power of conjugate transpose will be a conjugate row vector multiplying X power star on both sides. Ax equals to lambda X. We have X power star Ax equals to X power star lambda X. Clearly, A1 square plus B1 square plus so An square plus Bn square is real. Thus, eigenvalues of A are 1, 4. How do you know if a matrix is a Hermitian? For the given matrix, find its conjugate and then transpose the conjugate matrix. If the transpose of your conjugate matrix is same as the given matrix, then the matrix is Hermitian. How is a Hermitian matrix different than the symmetric matrix? If a matrix is equal to its transpose, then it is called a symmetric matrix, whereas the matrix is equals to the conjugate transpose, then it is a Hermitian matrix. Moreover, a Hermitian matrix have a complex numbers, whereas a symmetric matrix have a real entries. What type of eigenvalues do a Hermitian matrix have? Hermitian matrix always have a real eigenvalues. What is the determinant of the Hermitian matrix? The determinant of the Hermitian matrix is real in nature. Is addition of two Hermitian matrix again a Hermitian? Yes, addition of two matrix is always again a Hermitian matrix. Thank you.